Hi, I'm Paul Golding, Director of Frontier AI. This is a brief innovator's guide to deploying generative AI. The context here is the Wayne Gretzky quote, "Don't skate to where the hockey puck is, skate to where it is going." Broadly speaking, we can say that you could take existing strategy and enhance it with AI versus developing new strategy because of AI, which is a more innovative approach. This also equates to doing the same things better versus doing new things, and almost certainly means the difference between easy versus very hard. At the moment, we see a lot of hype that is associated with deploying large language models in existing businesses. This merely comes from taking a large language model and adding it to the business. People who do that soon discover there's a large gap between the hype and the reality of generating lasting, meaningful business value using large language models and generative AI. The easy thing to do is to take your existing business and add on or bolt on a large language model. Of course, because everyone can do this, it presents a low defensive moat. Moreover, it seldom fully works. Fully working is highly use case dependent. You have to take into account your error tolerance, hallucination risk, the actual KPIs that your business needs to develop and derive lasting value, and the regulatory constraints that you might face in your industry. Solving these meaningful way with lasting business value cannot be done using large language models out of the box. Fully working is highly task dependent. There's a huge difference between doing document classification, causal reasoning, and then the holy grail of prescriptive analytics, whereby the AI can make autonomous decisions. Almost no one's doing that. It's exceptionally hard and impossible just by merely bolting on a large language model. AI that works fully requires much more than just a large language model. It requires a number of other components which your innovation strategy must search for and find. Invariably, these would include data strategy, other AI technologies, and some novel solution hard to solve which presents the intellectual property challenge for your business. A large language model has three components, broadly speaking: language understanding, domain understanding, what it knows about the world having seen the training data, and then task understanding. There's many ways that you can attempt to modulate these different modes of the large language model. You can attempt to build a large language model from scratch, which invariably is expensive and requires significant engineering expertise. You can attempt to fine-tune a model to add in your domain-specific understanding from your enterprise. And there are myriad techniques for training the model towards a particular task, including prompt engineering. There's a vast set of intellectual property opportunities within this range of techniques, and they're evolving rapidly all of the time. Here we're only talking about how you optimize the large language model. The actual deployment of the model in a real business system to develop and drive lasting value is an order of magnitude more difficult. The solution is to adopt a holistic AI innovation, which means beginning with design-driven interpretation to expose the fundamental nature and challenges of your business from top to bottom. This must be married with model thinking, how AI actually works. Then, having had this understanding of fundamental capabilities, they can be married with the fundamental natures and challenges of the business to begin to develop meaningful ideas that are innovative and result in novel IP generation. This ideally is a virtuous circle and a capability that your business must develop to extract meaningful lasting value from AI. One of the challenges is that there are hundreds of papers published every week. We're only just getting started with large language models. Of course, this presents an opportunity because somewhere within that constellation of possibilities is potential white space where you can innovate. But the risk is that the rate of model innovation can easily exceed the rate at which you can develop intellectual property. In other words, some solution that you devise may in 1 week's time or 1 month's time or 3 months' time be replaced by improvements to the baseline models or some other open source innovation. This presents a challenge and speaks again to the need for a comprehensive holistic AI approach towards innovation. Let's look at some examples from real use cases. The first one is unsecured lending, where we found we had to deploy a plethora of AI technologies, not just large language models. But here highlighted in red was the core IP, where we had to first of all solve the explainability problem to explain why financial decisions were being made by the AI. This required novel, innovative effort and was the basis for innovation for this configuration. This second use case is the generation of websites from prompts. Here we had to dig beneath the capabilities of large language models to their underlying fundamental architectures called transformers and redeploy those to understand and analyze the structure of websites in the same way large language models analyze and understand the structure of language. But here, the key intellectual property, the key innovator, was the development of a data strategy. This involved the consideration of new products whose primary goal was to generate data versus revenue. The third use case here is business reviews. Look again how large language models is only a single component. Moreover, yet again, data strategy proved to be the key differentiator. And in this case, it was a very different approach, which was to collaborate with partners in an innovation network where they could collaborate and share data in a secure and private way in a win-win configuration. The final use case is travel. The travel industry is massive and there is already a high velocity of AI applied to this problem. In the particular use case we looked at, large language models yet again was only one component. What we discovered was the key to the solution in this use case was a highly reactive user interface. The only way that could be done was to deploy a novel predictive search algorithm that could return results and give the impression that the AI was almost reading the mind of the user. Such was its speed of response. We end on a cautionary note. We said at the beginning that it's relatively easy to add a large language model to an existing system and therefore does not constitute a defensive position. For incumbents, however, this is not quite true and almost counterintuitive. They can take a large language model and add it to their system easily, but because of the presence of proprietary large amounts of data that incumbents often have, this presents a high defensive moat. Typically, we expect that agile, small, fast-moving companies can be a threat to incumbents, but incumbents have access to the same sets of data, of large language model technologies, but they have access to proprietary data, which gives them an edge. This speaks yet again to the need to have a comprehensive AI innovation strategy. The mere deployment of large language models is insufficient to innovate meaningfully in most sectors. To know more about this, feel free to contact us and to talk about our holistic approach of combining design, innovation and AI to solve meaningful business problems and generate meaningful business value.